Do you need a way out? Are you always stuck in a burning building? Well, not anymore. Presenting the safety swing. The safety swing is a feat of engineering. Our product is aimed to safely evacuate people from a high elevation. The burning building situation is a perfect example of the safety swing in use. If the stairs and the elevators are blocked off, people on higher floors will need a safe evacuation route through the outside of the building. That, my friends, is what the safety swing is for. We are most proud of the compact design and minimal resources needed to build this product. High-quality materials that are strong and durable will be used for the job. I mean, look at the beautiful curves, sturdy construction, and shiny metal. With our patented design, we eliminate the need for an additional energy source, allowing for an energy-efficient design. Using our product, you can save your friends, save your wife or your husband, your children, your pet, your boss, your coworkers. You can even save some strangers. But don't forget yourself. Anyone that needs to evacuate is welcome on the safety swing. So buy the safety swing. Buy safe. A change in momentum can be shown by a change in mass or a change in velocity. The formula for momentum is P equals mv, with delta in front of mass or velocity depending on which one is changing. Our product uses the evacuee's velocity to carry them off the platform and onto the swing. This causes the basket carrying the evacuees to have a change in mass, or change in momentum. The swing system will then pull the evacuees back towards the building, changing the direction. When swinging, the swing will speed up as it swings toward the resting position, and then slow down when it reaches the maximum height it will swing to. Since change in momentum can also be change in velocity, this is also how momentum is involved with our product. The swing system will also eventually slow the evacuees down, where it lands at the ground level on the padding underneath, which is another place where a change in momentum is involved with our product.
We know that impulse is a change in momentum. When the safety swing lands on the ground, there is a certain change in velocity. This change in velocity is from when it's in the air and it has a certain speed, and then when it comes to its eventual resting position on the ground. This means we have a set change in momentum and therefore a set impulse. We know the equation for impulse is force times time. And if we have a bigger force, there will be a smaller amount of time that we need for that set change in momentum. For example, if we have a set change in momentum of 6, and we're only applying it for 1 second, that means we're going to have a force of 6 newtons. But if we have that same change in momentum of 6, but we're applying it for 3 seconds, that means we only need a force of 2 newtons. Therefore, you can see that if we increase the amount of time the force will take, we'll need a smaller force. We use this concept in the safety swing to protect our users. In order for the users of the safety swing to have a soft, safe landing, we needed to increase the amount of time it would take for the users to land on the ground. By doing this, we create a smaller force and protect them with more stability. To do this, we created a padding system. When the users in the safety swing land on the padding, this padding increases the amount of time it will take for them to land on the ground by providing some support. By doing this, the amount of force applied to the users when they land on the ground is less, and therefore it protects the users inside.
Newton's second law of motion can be observed in our product, the safety swing. It can be observed in 2 ways. First, when a person steps onto the safety swing, it will increase the total mass of the object. Newton's second law states that an unbalanced force will cause the object to accelerate depending on its mass. So when a person steps onto the platform and increases the total mass, there will be a downward force applied and cause an increase in acceleration. This can be observed in context with a visual. When a person steps onto the platform, it will increase the total mass of the swing and the person, which is the total mass. And this will cause a downward force and in turn it will cause an acceleration. Newton's second law is also consistent and can be seen when the safety swing has reached the bottom of its journey. It can be seen because the padding on the ground causes or produces an upward force onto the swing. And this, because the mass of the swing remains the same while the person is still inside it, the swing will decelerate or have experience a negative acceleration. And this makes sense because acceleration is a change in velocity, and the speed of the swing is changing due to the padding increasing the time the upward force is applied. As seen here, the safety swing has reached the bottom of its journey, and the padding is pushing upwards, is applying a force upwards, and this will cause a negative acceleration or a deceleration of the swing. This is also Newton's second law in action.
It's easy to get your very own safety swing. All you have to do is call now at 1-800-BUY-SAFE. That's 1-800-BUY-SAFE. Now you never have to be stuck in a burning building again. All you have to do is call 1-800-BUY-SAFE or go online at tinyurl.com/safetyswing. For the low price of 3 cents, you can get your very own safety swing at tinyurl.com/safetyswing. Now you have a friend in the physics business.